In this presentation, we are going to look at Gaussian elimination. So let's look at the question. Use Gaussian elimination to solve the following system of linear equations. So we have 2y plus 3z equals 2, 2x plus 3y plus z equals 4, 2x plus y plus 3z is equal to 2. In the first instance, what I'm going to do is write this out using a matrix notation. So 0, because we have a 0x here, plus 2i, so 0, 2, and 3. 2, 3, and 1, because plus z means plus 1 times z. 2, 1, and 3. That's the coefficients. And x, y, and z. And that's equal to 2, 4, and 2. So that is how we would write it out using matrix notation. What I'm going to do now is I'm going to write out the augmented matrix. And the augmented matrix is what we actually use in Gaussian elimination. So it's essentially this matrix here, which I'm going to call A, plus this matrix here, which is going to be called lowercase b. So let's write it out. 0, 2, 3. What we do is we put a partition of dots down to the middle of it just to emphasize its construction. 2, 3, 1, 4, 2, 1, 3, and 2. So that's the augmented matrix there, and we're going to use that in our Gaussian elimination calculations. So I have it written out here up in the top of the page, and what we have to do, well, I'm just going to put in the proper notation there. What we have to do is use elementary row operations to reduce this to row echelon form. Okay. On the right hand side, I have given the rows an individual unique number, R1, R2, R3. And as just for the sake of clarity, as I move through these slides, I'm going to actually give them new names, R4, R5, and R6. It's just to make it easier to follow. So, first off, we have R4. And that is going to be equal to R3. I'm going to put the bottom line up at the top, basically. So, 2, 1, 3, and 2. The next operation I'm going to do is I'm going to call the new line R5, and what I want to do here is to try and reduce, subtract one row from the other just to sort of reduce the augmented matrix. So what I'm going to do in this case, I'm going to subtract from R2, I'm going to subtract R3. So I'm just going to do a case-wise subtraction from R2 to R3. So 2 minus 2, that gives us 0. 3 minus 1, that gives us 2. 1 minus 3, that's minus 2. And 4 minus 2, that gives us 2. Okay, that's grand. R6, I'm just going to put in R1 here now. Okay. It has to go in somewhere. It has to be kept. So, and that is 0, 2, 3, and 2. Okay, so that's our first iteration, our first round of calculations. So we've actually made a good bit of progress in reducing this down to row echelon form. So let's go to the next slide here. That's where we ended up the last time, the last slide. So essentially what we're going to do is use more elementary row operations to reduce it down a bit further. So this time around, I'm going to leave the top row alone. So I'm going to call the top row R7, and that's just R4. Okay, so let's write that in. That's 2, 1, 3, and 2. The next thing we're going to do is we are going to divide R5 by 2, and I'm going to call it R8. So R5 divided by 2, we get 0, 1, minus 1, and 1. Okay. Now, next one we're going to do, we're going to call this new row R9. And what we're going to do here is we're going to subtract from R6, we are going to subtract R5. Okay. So we're working in the opposite direction. From R6, we're going to subtract 5. So from 0, we're going to subtract 0, that's 0. From 2, subtract 2, that's 0. From 3, subtract minus 2, that gives us 5. And from 2, subtract 2, that gives us 0. Okay, so that's where we're at now. And we're actually quite close to being finished now. So this is this was the last row, or the last iteration. And all we have to do here is just finalize it. So R10 is the next row, and that's simply R7 divided by 2, 1, a half, 3 over 2, and 1. R10, or R11, whoops, is simply R8, just repeated. 0, 1, minus 1, and 1. And R12 is going to be R9 divided by 5. And that is 0, 0, 1, and 0. Okay. So we made quite a bit of progress here. Now what we're going to do, so this is actually the system of equations in reduced echelon form. So what we can do now is return it back to like general equation, the notation. So we have x plus 1/2 of y plus 3 over 2 z is equal to 1. Y minus z is equal to 1. And z is equal to 0. Okay. So what we have to do here is to compute x, y, and z. Now automatically we can see down the bottom that z is going to be 0. Okay. So I'm going to call this line A, this line B, and this line C. So let's just look at this line B here for a second. We know that we know that z is equal to 0. So y minus z is equal to 1. Necessarily, essentially I'm just going to cross that out. Necessarily, y is going to be equal to 1. Okay? So look at the top line now. X plus half of y is equal to 1. Well, this part here goes to 0. We can just automatically ignore that from now on. Half of y is actually half of 1, and that's just a half. So x plus 1/2 is equal to 1. That means x is equal to 1/2. So x is equal to 1/2, y is equal to 1, and z is equal to 0. So that is the answer to the system of linear equations. And that ends this presentation.